The papers I chose for my presentation are the meta-evaluation of online and offline web search evaluation metrics, and also users' knowledge and information needs in information retrieval evaluation, and I will go through them in order. First, I'm going to present the metrics the first paper presented and share the results after data analysis. They investigated the relationship between offline and online metrics and actual user satisfaction. They also compared the performance of evaluation metrics in both homogeneous and heterogeneous search environments. They comprehensively meta-evaluated over 30 most popular IR metrics for many search tasks. They meta-evaluated some offline and online information retrieval metrics to see how well they infer user satisfaction in different scenarios. And the online metrics were usually connected to users' behavior data, such as their clicking ratio. In the case of offline metrics, they measured the quality of ranking algorithm, and these usually include average precision, which is AP, mentioned here, and it stands for average precision, and this is normalized discounted cumulative gain, and also ranked biased precision. In the case of online metrics, the simple fact is that the interactions between users and search engines reflect the actual user's experience in a natural usage environment. These are based on practical users' behaviors log, and they include click-based metrics such as CTR, which is click-through rate, and also binary value representing click, and also the number of clicks divided by the position of the lowest click, and as well as dual time based metrics, and such as query dual time, average of clicks, dual time, and etc. As shown in table 1, the researchers used 2 data sets as shown here, and it contained more than 2,000 search sessions collected with 56 search tasks in total. And figure 1 shows that users had to complete warm-up tasks to get familiar, and they were assessed after that. And in the search result page, they were not allowed to change the query. And also users were asked to examine 10 fixed search results provided by the system and end the search session either if the search goal was completed or they were disappointed and dissatisfied with the results. And they also had to label a satisfaction score to reflect their search experiences each time to proceed to the next task. Researchers adopted search engine result page level satisfaction rather than session level satisfaction because most offline metrics are designed to measure the quality of only one search result page. Both data sets contained query and corresponding task descriptions, information of ranked search results, as shown on search engine result pages, and 4-scaled relevance assessments of all search results, and 5-scaled user satisfaction annotations. And also users' interaction behaviors during the search process, including click-through, mouse hover, and dual time information. They also have a search task taxonomy, and which had 2 parts. And the first is search goal. The search queries are classified into navigational queries, informational queries, and also transactional queries. And cognitive level, which identifies 6 cognitive process dimensions: remember, understand, apply, analyze, evaluate, and create. But this paper only used remember and understand out of all 6 dimensions because they were easier to assess. Table 2 and 3. Table 2 shows an example set of the search tasks and their corresponding taxonomies, while Table 3 presents the number of search queries and sessions within different types of search tasks. This is a formula for evaluating the Z-score, which evaluates the satisfaction score, and satisfaction is actually very subjective, and it differs from user to user. So they calculated satisfaction for each user by this Z-score formula according to the label the scores users actually assign themselves. And this figure 2, the different colors show satisfaction scores from search sessions originated from different task categories. And generally, in all types of search tasks, the general trend is that users tend to give a high satisfaction score, as you can see. And the first chart is related to search goal taxonomy, and the second one is related to the cognitive level taxonomy. And Z-score is extremely low, it's like very low for informational search tasks compared with the other two type of search tasks, as you can see in the picture in the figure. And actually this is reasonable because in most navigational and transactional search tasks, users intend to find a specific website and a piece of information as a resource, which can often be satisfied with only one search result. And informational search tasks, users often have to read quite a number of search results to get a comprehensive understanding of the information need they have, and this is more difficult and time consuming. So users gave lower satisfaction scores in the search tasks which belong to understand, the green one. And because search tasks identified as understand category are considered to be more difficult than those identified to be remember category and task. And figure 2 actually makes it really obvious that users perceive different levels of satisfaction in different search scenarios. Table 4, in the meta-evaluation methodology, researchers use both Pearson correlation coefficient and concordance test to compare different evaluation metrics. As we see the size of the data points, here's of the navigational, as you can see, for the navigational is actually very small, and in the table 5 we can see that they computed cumulative gain, also known as CG, discounted cumulative gain, DCG, average precision, AP, what else, and ranked bias precision, RVP. And for DCG, they compared the performance of the metric calculated at different ranking lengths to investigate the effects of evaluation depth. For RDP, for RBP, they compared the metric performance when the persistence parameter was set to numbers shown in this table, which is suggested to be appropriate for all users, honestly, since it was written in the paper that impatient, neutral patient, and extremely patient users were all, this was very appropriate for all of them. And they also included expected reciprocal rank, which is ERR at the end. This is based on the Cascade user model and is suggested to better correlate with click-based metrics compared to DCG and other editorial metrics. We can see that ERR achieves the highest concordance with user satisfaction based on table 5, which is in line with the findings of this research. And this may be because the Cascade user model utilized in ERR better models user behavior that capture satisfaction. RVP achieves the highest Pearson correlation among all the metrics, which may indicate that a patient, but not extremely patient user ranked by a user model can best describe the characteristics of the tested user group. And from DCG, we can see that DCG 10 correlates user satisfaction slightly better than DCG 3 and 5, which probably indicates that metrics calculated based on a longer ranking length can capture more information and may have a better estimation of user satisfaction among all these offline metrics. CG has the lowest Pearson correlation and the concordance with user satisfaction. Discounted cumulative gain and also AP as well as ERR are all top weighted metrics while CG is not. And the performance of CG is especially remarkable in the case of navigational search scenario. Overall, we can observe that many offline metrics like DCG, RPP, and ERR have significant and moderate correlations with user satisfaction. The correlations and concordances between the online evaluation metrics and user satisfaction are shown in table 6, which is on the next page. Whereas you can see the highest correlation based on each interaction signals are shown in bolded terms. And online metrics generally correlates with user satisfaction negatively, which is reasonable because the offline metrics measure the quality of search result page based on relevance assessment, and users usually tend to feel more satisfied if the search results are high in quality. And high search effort can reduce user satisfaction. Maximum scrolling also correlates with satisfaction negatively. Max RR, min RR, and mean RR correlate with satisfaction positively. POC correlates with it also positively, as it is regarded as approximately the precision of examined results. The metrics based on click behaviors in general correlates more weakly with user satisfaction compared with dual time based metrics, because a clicked result does not always necessarily mean a high quality document. Some metrics based on a scroll, like max scroll, and dual time information, like some click dual, average click dual, and also query well time dual and time to last click, they have a stronger negative correlation with user satisfaction, meaning that scrolls and dual time information are quite important behavior signals. Time to last click has the best concordance with user satisfaction. And the last click actually in a search session is usually considered as a satisfied click, and therefore time to last click measures the time wasted before the user finds a satisfactory document. Query dwell time has the strongest Pearson correlation but relatively low concordance with user satisfaction. According to table 7, RPP and ERR usually perform the best among all offline metrics, while time to last click along with query dwell time perform the best among all online metrics. Online metrics have as good correlation and concordance. They achieve comparatively good performance without external relevance assessments. In search, goal-based task, taxonomy, the first one, top weighted offline metrics correlate quite well with user satisfaction in navigational search tasks. But the concordance test results may be discrete and not so reliable because of the limited number of data pairs. The Pearson correlation coefficient are extremely significant because in navigational search scenario, high quality results placed at the top position are especially important. Online metrics perform slightly worse in navigational tasks than in informational and transactional tasks because the search effort required in navigational search is usually less than that required in informational and transactional search. There's not much difference of the performance of different metrics from the perspective of cognitive, level-based taxonomy. The dual time based on metrics perform a little better in understand search scenario. And in table 8, with data collected from both homogeneous search environment, which was dataset 1, and the heterogeneous search environment, which was dataset 2, researchers investigated how different metrics perform in different search environments. Both online and offline metrics significantly correlate with user satisfaction, while they reflect satisfaction from different perspectives for different search tasks. Offline metrics better align with user satisfaction and homogeneous search. Offline metrics correlate extremely well with user satisfaction in navigational search, while online metrics perform comparatively better in informational and transactional search tasks. So offline metrics work better in homogeneous search. Online metrics outperform when vertical results are federated. And online metrics perform better than offline metrics in heterogeneous search environment because online metrics may be more sensitive to the effect of vertical results. Now I'm going to present the second paper, which is titled Users' Knowledge and Information Needs in Information Retrieval Evaluation. Researchers stated that the existing evaluation measures for information retrieval algorithms still lack awareness about the user's cognitive aspects and their dynamics. They often consider an isolated query document environment and ignore the user's previous knowledge and his or her motivation behind the query. The retrieval algorithms and evaluation measures that account for those factors limit the results' relevance to one search session, one query, or one search goal. The framework used here measures the relevance of a result document by examining its content and assessing the possible learning outcomes for a specific user. Researchers demonstrate the efficiency of the measure by comparing it to the knowledge gain reported by 361 crowdsourced users searching the web across 10 different topics. Their proposed measure is different, mostly in representing the information need in terms of keywords related to a topic or a goal. And the user must be exposed to the keyword information a certain number of times before considering them as a user that has attained the desired knowledge. They consider the user's previous knowledge. And again, their evaluation measure is not limited to one search session or query. They present an evaluation measure for a cognitive information retrieval system that measures document relevance, taking into account users' previous knowledge as well as their search goal. The research, the user's knowledge gets updated and changed over time. And similarly, the progress towards the user's goal is reassessed to check whether or not he or she has satisfied the desired need. Belkin introduced the notion of anomalous state of knowledge, ASK, as a motivating factor at the basis of an information need. Two users with different information needs might submit the same query but assess differently the usefulness of the return results. This is because of their different knowledge backgrounds. This paper actually focuses on learning-related search tasks where the user's need or goal is to learn about some topic. And in a learning task, users read specific documents to learn a set of keywords related to a topic. And each keyword that the user needs to learn for assignments have weights, and users also have to learn different range of keywords according to their previous knowledge. This is a personalized thing to each one of the users. And the amount of the user's knowledge about a word is the cumulative count of the number of times they have seen it before. And knowledge acquisition can depend on many behavioral factors like the dwell time and users' learning rates. As seen in figure 1, there are two users, A and B, having the same search goal, learning about subjects blockchain. And for this example, researchers selected the size of 5 vocabulary meat, and they choose these 5 nearest semantic associates of the topic term blockchain. Figure 1 shows that the knowledge base of users A and B before the beginning of the search session, these are in the clouds, actually, their previous knowledge. And as the figure shows, even though both users have the same search goal, each one of them has their own previous knowledge. Their previous knowledge, this is their previous vocabulary knowledge mentioned for all of the 5 keywords. Their previous knowledge affected the number of occurrences each time one of them has to read before reaching their goal. And for instance, user A has some previous knowledge about the keyword authentication, which is the first keyword, and actually 3 instances. Yeah. And also, it still has to read, user A has to read 10 occurrences of it to satisfy, while user B has no previous knowledge about the term authentication. About this keyword, it has to read like 13 occurrences of it to satisfy the same goal. Table 1 shows the first 10 results, documents, or web pages for the web query blockchain as returned by some search engine this year. And the table shows that for each web page, the number of occurrences of every keyword. It is to note that the keywords having the same origin with different tense or form were grouped, like Bitcoin, Bitcoins, they were grouped in once encrypted, and encryption, they were grouped in one other category. And next is evaluation framework that we're going to talk about. The researchers assume that the user subsequently reads through all documents returned by the retrieval algorithm until they have reached the learning goal. Notion of document relevance in this paper includes also the notion of document usefulness, with no redundant content with respect to users' knowledge, of course. And relevance does not only mean matching between the document and the user's need. Researchers' view of relevance compares the user's knowledge and their need with the content of the document. In the ideal situation, of course, the document should contain the exact number of occurrences needed. Sometimes the number of occurrences in the document is different from the number of occurrences needed, which is very probable, but when the needed number of occurrences for a given keyword is reached, the extra information is considered redundant. This research provided different equations about gain brought by documented rank or cumulative gain and normalized DCG. And the research questions are these two. Is there a relationship between the gain calculated by the proposed measure and the real gain reported by the users? And also, how does accounting for the user's prior knowledge affect the effectiveness of the measure? Before tasks were started, there was a pre-test, and also after tasks were done, there was a post-session test, and their questions were the same. They were identical questions in both the post and the pre-session. This was made available to be taken by the users once they felt their information need was satisfied. In the results, we can see that the effectiveness of the researchers' proposed evaluation DG is measured by its person correlation coefficient with the real user gain, whether it was personalized DCG or non-personalized DCG. Differences across the two conditions was computed using the independent t-test. And all the topics in the personalized approach marked a strong correlation than the non-personalized. The results prove that accounting for the user's previous knowledge is closer to reality. We can say that research question 1 is supported, and the user's previous knowledge, when available, must be taken into account at the start of a search session. And the results also answer the research question number 2. Accounting for the user's previous knowledge significantly influences the game. Overall, this research presented an evaluation measure for cognitive retrieval algorithms that consider the user's knowledge and search goals. Researchers measure accounts for the state of the user's knowledge before starting their search session, and also considers the fact that knowledge is a dynamic feature and the user's knowledge representation is gradual and increases monotonically. The average of the proposed framework is that it is not limited to one query or one search session, and the approach tracks the user's knowledge and progress to their goal throughout the whole interaction. When the user changes the query, the knowledge state and the progress they made are preserved. They will be considered when measuring the relevance of the new documents in the new session or query. Authors also proof that importance of accounting for the user's previous knowledge when they were defining the user's need. I thought this was really related to the previous paper, and it was really interesting to me. Thanks for watching this presentation.